You just dropped $80,000 on a brand new tractor. The paint still smells fresh. The cab is spotless. You fire it up for spring planting, drive it into the field, drop the plow, and the entire machine dies. Dashboard lights up like a Christmas tree. Error codes you've never seen. The dealer is 3 hours away and booked solid for 2 weeks. This wasn't a lemon. This was the future of farming. At least that's what the manufacturers promised. What farmers got instead was reliable iron turned into an electrical nightmare. Machines they couldn't fix. Dealers who couldn't diagnose them. Manufacturers who wouldn't stand behind them. The 1980s marked the shift from mechanical simplicity to electronic chaos, and it nearly destroyed the reputation of an entire generation of tractors. The late 1970s represented the peak of purely mechanical tractor design. These machines used systems farmers could actually understand and repair themselves. No computers, no sensors, no diagnostic equipment required. Take hydraulic draft control, the system that automatically adjusted implement depth based on soil resistance. It worked through a simple mechanical linkage connected to the 3-point hitch. When the plow hit harder soil and the tractor started to bog down, the draft control sensed the increased load through mechanical leverage and raised the implement slightly. Pure physics. A farmer could adjust it with a wrench and diagnose problems by watching how the linkage moved. Power shift transmissions operated the same way. Hydraulic pressure controlled by mechanical valves and linkages. You could see the shift forks move. You could hear the clutch packs engage. When something went wrong, you could trace the problem through the system with basic tools and common sense. This mechanical simplicity mattered desperately during the farm crisis. By 1980, American farmers were drowning in debt. Land values were collapsing. Interest rates hit 20%. A major repair bill could push a family operation into bankruptcy. The ability to fix your own equipment wasn't just convenient, it was survival. Farmers became expert mechanics out of necessity. They rebuilt transmissions in their shop. They fabricated hydraulic lines. They kept 30-year-old tractors running because they understood every component. The machines were simple enough that knowledge could be passed from father to son, and parts were generic enough that you could find them at any farm supply store. The irony is brutal. Manufacturers had spent decades perfecting these mechanical systems. By the late 1970s, they had finally gotten it right. Tractors like the International 86 series, the John Deere 40 series, and the Case 90 series represented the pinnacle of mechanical reliability. These machines could run for 10,000 hours with nothing more than routine maintenance, and then the manufacturers abandoned everything that made them great. The corporate logic seemed sound at the time. Electronics were revolutionizing every other industry. Cars were getting fuel injection and digital dashboards. Why shouldn't tractors follow the same path? The marketing department saw an opportunity to differentiate their products with advanced technology and precision control. The engineering department saw a chance to solve old problems with new solutions. But nobody asked the farmers if they wanted any of this. And nobody tested whether the technology could actually survive in the environment where it would be used. The early 1980s triggered a corporate arms race. Every major manufacturer scrambled to add electronic controls, terrified of looking outdated compared to their competitors. If your rival's brochure showed a digital display, you needed 2 digital displays. If they had electronic draft control, you needed computerized hydraulics. Case IH led the charge with their electronic draft control system. Instead of a simple mechanical linkage, they installed load sensors on the 3-point hitch, a microprocessor to interpret the signals, and a digital display to show the operator what the computer thought was happening. The system promised precision that mechanical linkages could never achieve. Automatic adjustments measured in milliseconds, sensitivity that could detect the slightest change in soil resistance. John Deere countered with their quad-range transmission, which used electronic controls to manage what had previously been purely hydraulic shifting. Solenoids replaced mechanical linkages. A computer decided when to shift based on engine load, ground speed, and operator input. The dashboard featured buttons instead of levers, and a display that showed which gear range you were supposedly in. White and their AGCO successors pushed computerized hydraulic systems that attempted to manage implement control, remote cylinders, and auxiliary functions through electronic valves and processors. The marketing materials showed farmers effortlessly controlling multiple functions from a single joystick, all managed by silicon chips. The corporate pressure was relentless. Look modern or die. It didn't matter whether the technology was actually ready for farm use. What mattered was staying competitive in the showroom. Dealers needed something new to sell. Marketing departments needed features to advertise. Engineers who raised concerns about reliability were told to make it work, and the launch date wasn't negotiable. Farmers were promised precision, efficiency, and ease of use. The brochures showed clean tractors in perfect fields, with smiling operators touching buttons instead of pulling levers. The reality would be far different. These systems were developed in climate-controlled laboratories and tested on manicured company farms. Nobody properly validated them in the actual environment where farmers worked. Fields filled with mud that could swallow a boot. Dust so thick you couldn't see 50 feet. Temperature swings from 20 degrees below zero to 110 in the cab. And vibration that could rattle bolts loose. The sensors were designed for clean rooms, not for being caked in dirt and manure. The wiring harnesses were built to automotive standards, not agricultural ones. The computer modules had the same environmental protection as the processor in an office calculator. The connectors corroded when exposed to moisture. The circuit boards cracked from vibration. But the tractors shipped anyway. Tens of thousands of them were sold to farmers who trusted the brands their fathers and grandfathers had relied on. Farmers who had no idea they were about to become unwilling beta testers for technology that should have spent 5 more years in development. The first cracks appeared almost immediately. The sensor epidemic hit first. Electronic load sensors mounted on 3-point hitches were exposed to everything agriculture could throw at them: mud, fertilizer, hydraulic fluid, road salt, and constant vibration. Moisture worked its way into connectors. Dirt accumulated on sensor faces. The result was either no signal at all or wildly inaccurate readings that made the system behave erratically. A draft control system that couldn't sense load properly would either bury the plow so deep the tractor couldn't pull it, or lift the implement completely out of the ground while the operator watched helplessly. Farmers learned to simply turn the electronic systems off and control depth manually, making the expensive technology completely worthless. Power shift transmissions became mechanical Russian roulette. The electronic solenoids that controlled shifting were sensitive to voltage fluctuations and contamination in the hydraulic fluid. When they failed, transmissions either refused to shift at all, leaving you stuck in one gear, or shifted continuously on their own, hunting between ranges while you tried to work. The Case 94 series became notorious for electrical gremlins that defied diagnosis. Tractors would start perfectly one day and refuse to turn over the next. Dashboard warning lights would illuminate randomly. Systems would fail intermittently, working fine when you brought the tractor to the dealer, failing again the moment you got it home. The IH-50 series power shift had its own special nightmare. The electronic control module that managed shifting was mounted in a location where it was exposed to engine heat and vibration. Solder joints cracked, circuit boards warped. The transmission that was supposed to be the most advanced available became the most unreliable. Wiring harnesses turned into the biggest disaster of all. Manufacturers used automotive-grade connectors that weren't designed for the harsh environment of agricultural equipment. Connections corroded, pins backed out from vibration, wires chafed through where harnesses rubbed against frames and brackets. The worst part was the intermittent nature of these failures. A corroded connection might work fine when the tractor was cold, then fail when everything heated up and expanded. Or it would fail when you hit a bump, then start working again when you stopped. Dealers couldn't diagnose problems they couldn't reproduce. The dashboard became a light show of error codes that meant nothing to anyone. The operator's manual included pages of diagnostic codes, but the explanations were useless. Code 23, sensor malfunction. Which sensor? What kind of malfunction? The manual didn't say. The dealer didn't know. Even the factory technical support line couldn't always tell you. Dealers were drowning. They didn't have the diagnostic equipment these systems required. The scan tools cost thousands of dollars, and manufacturers were slow to provide them. The training was inadequate. A 2-day seminar couldn't teach mechanics who'd spent their careers working on mechanical systems how to diagnose electronic problems. The warranty trap closed on farmers with perfect timing. These electronic systems typically lasted just long enough to outlive the factory warranty, maybe 18 months, maybe 2 years. Then the failures started, and the repair costs were devastating. A failed electronic control module could cost $1,500. The diagnostic fee just to identify the problem was $200 before any actual repair. Sensors ran $300 each. A complete wiring harness replacement could hit $5,000. Farmers watched $80,000 machines become yard art. Too expensive to fix, too new to abandon, too unreliable to depend on. They kept their old mechanical tractors running as backups, which meant they were now maintaining 2 complete lineups of equipment instead of 1. The repair bills were just the beginning. The real financial devastation came from downtime during critical windows when every hour mattered. Spring planting operates on a razor-thin timeline. You have maybe 2 weeks when soil conditions are right, dry enough to work, but moist enough for germination. Miss that window, and your yield drops 10, 15, 20%. An electronic failure that sidelines your tractor for 3 days, waiting on a part, doesn't just cost you the repair bill. It costs you an entire season's income. Harvest is even worse. Corn and soybeans have optimal moisture windows. Too wet, and the grain won't store. Too dry, and you lose yield to shattering. When your tractor dies in the field, and the dealer says the diagnostic computer won't arrive until next week, you watch your crop deteriorate while the calendar moves against you. Farmers started calculating the true cost of these electronic systems, and the numbers were staggering. A power shift transmission failure during harvest could mean $5,000 in repair costs, plus $20,000 in lost income from delayed harvest. An electronic draft control failure during planting could cost $3,000 to fix, plus $15,000 in reduced yield from poor seed placement. The parts racket made everything worse. Electronic control modules were proprietary. only available from the dealer, no aftermarket alternatives, no rebuilding options. A module that probably cost the manufacturer $200 to produce sold for $1,500 at the parts counter. And you needed the exact part number for your specific tractor model and year. Generic solutions didn't exist. Farmers who had always kept one primary tractor were now forced to maintain 2 or 3 machines. The new electronic tractor, for when it was working. The old mechanical backup, for when it wasn't. And maybe a third ancient machine, just in case both of the others were down simultaneously. Equipment costs effectively doubled, while farm income was collapsing. The diagnostic fee structure created its own trap. Dealers charged $200 just to connect the scan tool and pull the codes. That fee was non-refundable, whether they fixed the problem or not. And half the time, the codes pointed to multiple possible causes. You would pay $200 for diagnostics, another $1,000 for parts they thought might fix it, and if that didn't work, you would pay another $200 to diagnose it again. This hit farmers who were already underwater from the farm crisis. By the mid-1980s, thousands of family operations were months away from foreclosure. Land values had dropped 40%. Debt payments consumed every dollar of income. A $3,000 tractor repair could be the final straw that forced a farm auction. The corporate response was breathtaking in its callousness. That's just the cost of modern farming. As if farmers had any choice. As if the manufacturers hadn't created this problem by rushing half-tested technology to market. As if the complexity was necessary rather than a marketing gimmick that backfired. But manufacturers kept pushing forward anyway. The reason was obvious once you looked at the business model. Planned obsolescence meant farmers would need to replace tractors more frequently. Proprietary parts meant higher margins. Dealer service revenue became a profit center instead of a cost center. The more complex the machines, the more money manufacturers made from the service side. The death of the shade tree mechanic was complete. Farmers who could rebuild a diesel engine, who could fabricate parts on a lathe, who could diagnose a hydraulic problem by listening to the pump. These men were helpless against a failed sensor or a corrupted software module. Their knowledge was suddenly obsolete. Their skills were worthless. They had to pay someone else to fix machines they used to repair themselves. Case IH should have dominated the 1980s. The Magnum series had the power, the comfort, and the features farmers wanted. But the electrical gremlins destroyed their reputation. Farmers who bought early Magnums and spent thousands on repairs told everyone they knew to avoid them. Word spread through coffee shops and farm auctions. The brand that had built some of the most legendary tractors in history became a punchline. White farm equipment collapsed under the weight of multiple problems, but reliability issues accelerated their death. When farmers can't trust a machine to work, they won't buy the next model. White's sale to AGCO in 1991 marked the end of a once proud American manufacturer. Allis-Chalmers faced the same fate. Their final tractors suffered electrical problems that sealed their reputation as unreliable. The company that had pioneered fuel efficiency and innovative engineering couldn't survive the transition to electronics. They stopped building tractors in 1985. The electrical nightmares of their last models ensured nobody mourned the loss. John Deere survived because they made a calculated gamble. They had the largest dealer network in North America. When their electronic systems failed, and they did fail, Deere dealers had the diagnostic equipment, the training, and the parts inventory to fix them quickly. Farmers paid a premium for Deere tractors, but that premium bought them support the other brands couldn't match. The irony cuts deep. The simplest tractors of the era became the most valuable. Ford's TW series used mostly mechanical systems with minimal electronics. Today, a clean TW35 sells for more than it cost new because farmers know it'll actually work. The complex electronic marvels from the same period sit in salvage yards, worthless except as parts donors. The technology finally caught up to the ambition by the 1990s. Sealed connectors replaced exposed terminals. Environmental ratings improved. Processors became more robust. Software got better. By 2000, electronic controls were genuinely superior to mechanical systems. But that didn't help the farmers who bought the beta versions in 1983. An entire generation of 1980s tractors carries a permanent stigma. Farmers who remember the electrical nightmares still won't buy them, even 40 years later. A 1978 mechanical tractor commands respect and decent money. A 1985 electronic version from the same manufacturer is considered junk. The machines themselves weren't bad. Strip away the electrical systems, and you'd find solid engines, strong frames, and capable hydraulics. But the electronics ruined everything they touched. Good iron destroyed by rushed technology that should have stayed in the lab for 5 more years. Today, those 1980s nightmares are collector curiosities, not working iron. Enthusiasts restore them for shows, replacing every electrical component with modern equivalents just to make them reliable. The tractors that were supposed to represent the future became historical footnotes, cautionary tales about the cost of pushing technology before it's ready. The 1980s proved that newer isn't always better, especially when farmers become unwilling beta testers for half-developed technology. These weren't bad tractors ruined by bad electronics. They were good tractors, destroyed by rushed electronics that manufacturers pushed to market before the technology could survive real farming conditions. Subscribe if you want more stories about the iron that changed farming, for better or worse.